let's finish this video series with talking about forecasting for monthly data, monthly seasonal data. And let's also talk about analyzing which method is best depending on your data here. Okay, so let's say, for example, we have, again, the multiple regression model with the monthly seasonal data. And we want to forecast how many homes we expect to sell in January of 2015. Let's have a look at that data again. Okay, so here it is, this guy right here, and we're looking to forecast for January of 2015. So this one right here. Okay. Okay, so back to our slides here. So for January 2015, that's the very first time period, so T will be 0. We always start our coded variable at 0. Or that's what I do, so I'll do that consistently for all these forecasting methods. If you'd like, you can start it at 1, but I recommend starting at 0. Okay, and then if it's January of 2015, well, we've set January, or we've had January as the dummy variable that we ignore. Since we excluded the January, and we're talking about January, all the other months, so February through to December, are the dummies that we included. They will all be 0, all those month 0 ones. So let's have a look here. So February, March, April, all the way through to December, we'll put 0s for all of those because we're not in any of those months. And we're also in time period 0, so we're going to put a 0 there. Guess what we're going to get? Well, we're going to put 0s for each of the variables, and we're just going to be left with the 137. Well, guess what that is? That's our y-intercept. Okay. So kind of just another way of making sense of that y-intercept. And that's why I like also starting my coded variable at 0, so that my y-intercept is exactly the same as my first month of data in this case, or my first time period of data. Okay, let's talk about forecasting into the future. So let's say May of 2020. Okay. So let's have a look in the data set here at what this will look like. So T should be 64. Let's have a look at that. So here we are looking at the data set. We're going to go all the way down to May of 2020. So here I have it highlighted right here. That would be coded time period 64. Okay, I've just let the time periods keep running until the end of the year for December 2020. So that's 64. Okay. Okay, and then the May dummy variable would be a 1. All the other ones would be 0s. So it's going to look like the following. We're going to put in 1 for May, and then 0 for all of the other ones here, and a 64 for the time. Okay, and our sales are going to turn out to be 281,260. And let's just have a look here. So again, here is that equation we're working with. So we've just plugged in all of our variable values. We get 281,260. So we expect to sell 281,260 homes in the United States in May of 2020, assuming the market keeps behaving as it has been historically. Okay. Good. Now, let's just wrap up this video lecture series by talking about how to determine which method is best on seasonal data. So very first thing you should always do before you ever do any forecasting methods, do a scatter plot of your data set. Does the data appear to be seasonal? Are there peaks and valleys that happen at the same time each year? If there are, then you most likely have seasonal data. Then, next question to ask yourself, both the methods we've just looked at are what are called extrapolation methods, where we're using the data itself to forecast future data. So, question, do we think this data set is suitable for this extrapolation type method? So it will not be suitable if the following is true. There's been some major world event. So right now we're under coronavirus quarantine. That's a big major world event. There was another really big one that happened in 2007, 2008. Throughout that period would have affected our data as well. So maybe an extrapolation method is not appropriate. If it's not, what I recommend is adding more X variables to a multiple regression. Thinking what else would adapt or change as the market drastically changes. Use those predictor variables as well to feed into your regression, but that's a future topic. Okay. If there hasn't been any major world events, or if there hasn't been any other large change in your data, then keep going. So with some other large change, maybe there's a change in management, maybe the company got bought out, maybe something else happened. And so just have a look, see, or think back. Use a lot of your intuition here for this step 1, and ask yourself, do I think anything big happened in the time period I'm looking at that might have affected my data? If nothing you think has happened, then carry on and just try out your Holt's Winters method and try out Holt Winters and try out our regression with our dummy variables. And then best is to calculate the RMSE for each method, that root mean squared error on your errors. And here it is. Remember, your errors for regression are also called your residuals. Okay, and your forecasts were called your predicted values. We saw that in a previous video. Let's also, what we saw in a previous video as well, once we get our RMSE, let's also minimize it for the Holt Winters. We're going to do that by changing our alpha, beta, and gamma within the solver. And then finally, choose the best method by choosing the one with the lowest RMSE. Once you've chosen that, and if you think everything else has been satisfied in all the previous steps, then go for it and forecast for future data. So if you'll see here on this last slide, this is actually also an active graph. You can click on it and take a look at this data here. So this is the real housing market data, and here are the forecasts for the rest of 2020. So here they are all the way through to December of 2020. Okay, so go for it and forecast into the future if you think that everything has been satisfied here. And looking at this purple line, this would be our sales in December of 2020 if this were true, or if the data kept behaving as it previously was. Okay, that concludes our forecasting for seasonal data video lecture series here. Thanks for watching.